In this lesson, you are going to learn about the molar mass. What is a molar mass? We say that a molar mass is the mass of 1 mole of a substance. The molar mass is expressed in gram per mole. The molar mass for the elements is known as relative atomic mass. Examples of elements are like sodium, potassium, carbon, sulfur, phosphorus, etc. And the molar mass for the molecular substances is known as relative molecular mass. Examples of the molecular substances are like sulfuric acid, nitric acid, sodium nitrate, magnesium sulfate, etc. Now, how do we find the molar mass of substances? Here we have various examples through which we are going to see how do we calculate the molar mass of different substances. Now, it states that calculate the molar mass for each of the following: A. Aluminium, B. Oxygen gas, C. Sulfuric acid, D. and 3-carbonate, E. Calcium chloride dihydrate. And we are given the list of all atomic masses for the elements used in these compounds. Now let us start the solution. Part A. We are required to calculate the molar mass of aluminium. You have to know that when you are asked to find the molar mass of an element, you have to take the value of its relative atomic mass from the periodic table. For example, here, the molar mass of aluminium, we are given that it is 26.982 gram per mole. So, the molar mass of aluminium is 26.982 gram per mole. The second part, part B, is the molar mass of oxygen gas. How do we find the molar mass of oxygen gas? You have to know that oxygen gas exists as a diatomic molecule. So, it means that oxygen gas has more than one atom. To get the molar mass for any compound or any molecule, you have to take the sum of relative atomic masses for all atoms present in that molecule. Now, for oxygen, we have 2 oxygen atoms. Here, we take the mass of 1 oxygen atom times 2 because there are 2 atoms of oxygen. Now, the mass of 1 oxygen atom is given as 15.999. So, we take 15.999 1 oxygen atom times 2 because there are 2 oxygen atoms, whereby we get, let us compute this. When we take 15.999 times 2, we get 31.998 gram per mole. So the molar mass of oxygen gas is 31.998 gram per mole. In C, we are required to find the molar mass of sulfuric acid. To get the molar mass of sulfuric acid, you have to sum up the atomic mass of all individual atoms present in sulfuric acid. So we have 2 hydrogen atoms, 1 sulfur, and 4 oxygen atoms. Now let us find out the mass of each and add them. So it will be equal to hydrogen. The relative atomic mass of hydrogen, we are given that it is 1.008. How many are they? They are 2. So it is times 2. We add the mass of sulfur. We have 1 atom here. Sulfur, the relative atomic mass of sulfur, we are given 32.066. We add, here we have 4 oxygen atoms. Now it is the mass of 1 oxygen atom times 4. 1 oxygen atom has the relative atomic mass of 15.999. times 4 because there are 4 atoms. Now, let us compute it. When you take 1.008 times 2, you get 2.016, and 32.066 is written as it is because we have only 1 atom of sulfur. And when you take 15.999 times 4, you get 63.996. When you sum up these 3 values, you get 98.078 gram per mole. So this is the molar mass of sulfuric acid. After that, let us see part D. D, we are required to find the molar mass of iron 3 carbonate. As you see, the iron 3 carbonate is this one. Now, let us find out the molar mass of this. We take the relative atomic mass of iron times 2 because we have 2 atoms of iron. Now, the relative atomic mass of iron we are given is 55.845. So, it is 55.845 times 2 because it is times 2 because we have 2 atoms of iron. We add the value obtained, we add with, here we have carbon. The relative atomic mass of carbon is 12.011. 12.011. But this carbon is multiplied by 3 because outside here we see there is 3. Now it is multiplied by 3. After that, we add oxygen. The relative atomic mass of oxygen is 15.999. Now we add 15.999 times, inside there are 3. So it is 1 times 3. 1 oxygen atom, the mass is this one, times 3. But also outside we find another number, there is 3. So it is 3 times 3. What do we get now? Let us compute this value. When you compute 55.845 times 2, you get 111.69. And 12.011 times 3, you get 36.033. And finally, when you compute 15.999 times 3 times 3, you get 143.991. And the sum of these 3 values is 291.714 gram per mole. This is the molar mass of iron 3 carbonate. After that, let us see the last part, which is E, to calculate the molar mass of calcium chloride dihydrate. How do we calculate this? Let us see. The same as we have calculated the molecular mass of the previous molecular substances. Also, calcium chloride dihydrate is calculated in the same way. We have calcium here. The relative atomic mass of calcium, we are given that the relative atomic mass of calcium is 40.078. 40.078. As it is only a single atom, we write it as it is. We add. The next one is chlorine. The relative atomic mass of chlorine is 35.453. 35.453. But how many are they? We have 2 atoms of chlorine. Now we multiply by 2. We add 2 molecules of water. So it is 2 times the mass of 1 molecule of water. 1 molecule of water is made up of 2 hydrogens and 1 atom of oxygen. Now, let us start with hydrogen. What is the relative atomic mass of hydrogen? We're given is 1.008. Now, it is 1.008. But we have 2 atoms, so it is times 2. The answer obtained here, we add the mass of 1 oxygen atom. We are given is 15.999. 15.999. Now, let us compute this to get the answer. When you compute, we take 40.07 as it is, as you see here, because it is only a single atom of calcium. We add 35.453 times 2, we get 70.906. And we add 1.008 times 2 plus 15.99, where we get 18.015 times 2, as you see here, because we have 2 molecules of water. Now, when we multiply by 2, we get 36.03. When we sum up these 3 values, we get 147.014 gram per mole. Now, the molar mass of calcium chloride dihydrate is 147.014 gram per mole. Therefore, this is the way we calculate the molar mass of various substances. So, whenever you're asked to find the molar mass either of a molecular substance or an element, we do as I have shown you here. After this lesson, I'm going to write the homework for you to practice in order to see if you have understood. And the answer for each question will be in the first comment. This is your homework. The question states that calculate the molar mass for each of the following. 1. The molar mass for potassium. 2. Nitrogen gas. 3. Calcium nitrate. 4. Calcium hydroxide. 5. Copper 2 sulfate pentahydrate. And this is the list of various atomic masses of the elements used in these given substances. So I hope you are going to do this homework nicely. After saying so, I thank you for attending this session. I welcome you in the next sessions. Have a nice moment.